All right. Priority scheduling. Priority scheduling is something against fairness, right? Fairness means that I have a bunch of processes. Every process should have a fair share. I don't know, it's about time or about resources. But if it's about time and resources, okay, basically you will have equal share among each, not each, okay, all processes, no matter you're launched from roots or launched from ordinary users. Now, priority means that basically you inject some more control to break the fairness. We have two kinds. And really, we can write program to change your priority. Okay? Or not just write program. Sometimes it's just a command. So what is that? Two classes. One is called static priority. Means that when you create a process, the priority is fixed and you cannot change. Another is dynamic. Dynamic means that while you're running the process, the priority may change. Okay? I don't know whether it's because of the scheduler change or because of the outside commands, but it has a way to change. Of course, nowadays system is dynamic. Okay? It will change priority while you're running it. Okay? So basically, what is the static priority? Static priorities means there is a priority classes, and in the current 2.6 means a 3.0 version is also very close to 2.6. We have 100 priority classes, okay, for current Linux system, and that means that this is just a miniaturized version of a scheduler. Okay, and we have different priority class, and every class usually is a round robin queue within each class. Okay, so how can you change your priority? There's something not included in the PowerPoint. I can share with you what this is. Okay, so basically I need to go back to my Linux in order to show you. Yeah, this is my Linux. Can you see clearly? Good. Okay, so there is a command called nice. Nice. Okay, so the command nice is very interesting. Okay, take a look at the description. Nice. Run a command with modified scheduling priority. Why this number? No. This command is called nice. It means you are being nice to others. You are being nice to others. Okay, can adjust. What is the adjustment? The niceness is not a priority class. It is how nice you are. How nice you are. Okay, so there is a niceness to start with a negative number, -20 to positive number 19. Okay, and look at the description. If it is a negative number, smallest negative number means that most favorable scheduling. I do the conversion. You are taking up most of the CPU attention. That means negative nice means not nice, right? You are not nice to others. If you go to 19, least favorable means that you are a nice guy, right? If you are a nice guy, you cannot take anything, right? You usually cannot take CPU. Yeah, in this case, it's CPU. Okay? He is a nice guy, he's a bad. Okay? And what is the interesting thing? Okay? Let me look at this. There's no such description in the main page. Okay? So let me tell you the secret. Who can change the nice value? Everybody can. Okay? You can go to the terminal and type. Okay, say nice. Nice top is nothing. Okay, nice. I have a while loop. I need a while loop. Okay, while one. Let's see. Okay. Yeah. Wait for a moment. I'm very good at writing a while loop. One. Good. Okay, so there's a while loop. Now, how about I call nice? Okay, how about I call nice? Now, before I call nice, I first fire one in the background. Okay? And what is this here? What is here? NI here. Yeah, I cannot highlight it. Okay, wait a moment. Yeah. Wait a moment, I launched something to help me. Good. That's what? NI means nice values. So every process of our what is A? Long ago. Oh. Oh yeah. That's why teaching operating system is dangerous. I don't know. I put a. Yeah, look at the time. How long it is? Oh no. Okay, so normal, nothing. Oh, that's why my computer is so slow. Okay, I don't know. Now I fire another guy. Look at the main page. Okay, so there's an option. -n is for the niceness. So I want to be the super nice guy, 19. Okay, and I start the while one. Super nice guy, -n, 19. While one. Okay, so it's fire. So I send it to the background. So this is a slight difference in the CPU usage, right? Because my system don't have too many CPU hungry processes. Okay, so although I'm being nice, okay, nice is 19. Although I'm being nice, so it's not a giving way to other processes. So how about I do things like this? 1, 2, yeah. 1, 2, 3, 4, 5, 6. Okay. Yeah, I will remember to kill them. Now look at the light sky. Where are you? Eh? Where are you? Oh, gone. Too nice. Ah, I found it. Okay, nice guy. Here. Right? This is a nice guy. Too nice. Okay, 0 CPU resource. Okay, so this is the cost of being nice. Okay, see, this is a nice guy. So you can adjust the priority. Okay. Oh, I know. I need to use this first. Okay, good. Now how about I try to be a evil guy. -20. Ooh. Can I? Cannot. So, ordinary users, you can only be a nice guy. Yeah, you cannot be evil guy. So who can? Of course, sudo make me a sandwich. I do it. I forgot to send it backward. Okay. Should be make it in a string. Okay. Okay, good. So let's check. So this is the only bad guy. Yeah. Being not nice, not meaning I take all resources. Okay. It still allow other resources to run, or I cannot do the SSH, right? So now I will launch other one. Okay. Okay. So I launch others. What happened? 1, 2, 3, 4, 5, 6. Take a look at the bad guy. Can you see what happened to the bad guy? Did the bad guy receive fewer resources than before? Only about 1%. Previously, it's still 100. Oh, great. So being evil is great, right? Yeah. But remember, more than 100% because I have more than one core. Okay. So being an administrator, you can fire an evil program, but others can only become nicer. Okay, so this is called nice is to change the priority. Okay, but this priority still cannot take control of the entire system. Okay, so a zombie where? Who got killed? You find set. Zombie cannot run. You mean I have a zombie process here? Oh shoot. Maya. Okay. Oh, yes you do. Dangerous. So let me check before I go on. Okay. Good. 邊度 Where? 右上角 Oh, okay. Let me check. One zombie, PS, ELF, quick grab, set, block. Okay. I go back to office to check. Okay. Yeah, zombies doesn't hurt. Okay. Or only hurt your mouse. Okay, not hurt my system. Okay, so this is about basically this is about different treatment for processes. And the nice value is an advanced control. Advanced control meaning that, okay, I allow you to submit a job with a higher priority, but it is not about this priority class. Okay, they are not the priority class. Okay, the nice value is within one class, I give you extra values to distinguish whether you will schedule first or schedule last. Okay? And it's not a static priority. If it's static priority, it means that at the birth, you know that where you are. Okay? And say I give you a simulation here. Simulation is like this. Say I start the system with this configuration. The priority 4 is the highest priority. So I will ask this priority 4 process to execute first. Now usually this high priority process must be short-lived. Must be short-lived. Don't create high priority process which is long-lived. Okay? I will show you why. Okay? Here is something that you have to tackle first. So the CPU run on it, and because within each group around robin, if this guy require more CPU resource, then it will close up all the quantum, and then go to this guy, and so on and so forth. Okay? So, say for example, these two guys have finished running because they are short live. Then we will go to a next party, and if the next party 3 is empty, I will go to 2. If it's empty, I will go to 1. Okay? But suddenly, if a high priority process come in, okay? Now usually if it's a priority scheduler, it should be implemented with preemptive properties. If I cannot preempt, why I need priority, okay? So if a new process come in with high priority, it will preempt the entire system and run it. Now think of, you can discuss with neighbor, think of the consequence. What is the consequence if this new admitted to the scheduler processes with highest priority is a wild one program? What will happen? If it's a wild one program, long life, won't die. It won't die. So what will happen? If it's wild one, will all these guys here receive CPU attention? No, never. It won't be able to receive any attention. Okay, if it is allowed that you submit a one-on-one process using the highest priority. Okay, unlike my previous demonstration is not this thing. Okay, this is another thing. Okay, but another way to control priority. So basically, don't submit high priority jobs. Okay, so this message is for elite class students. Okay, later on we will hack the scheduler, and don't try to schedule things using this. Okay, if you really want to tackle set this kind of things, okay, I recommend you don't touch your Linux, but touch your Windows. Okay, so this cannot be recorded. So let me launch a notepad. Notepad, where are you? Right,打個 N 咪得。Yeah, okay. Yeah. Whoa. How about I change the notepad to the real time? Oh, real time means that the highest priority. Okay. What if this notepad becomes the highest priority? Okay, that means that the keyboard is extremely important. Okay, you type in. First of all, you may not understand what is it. Okay, this is a way to change the priority. And what is affinity? Affinity means a process can choose stay with which core, which CPU core. Okay, Linux also can set affinity. Or set affiliation. Okay, so in Windows we can change which CPU core you love to stay with, in order that you won't suffer from any loss from context switching. Yeah, there's a control. Okay, that's why previously I told you about the context switching penalty. There exists a way to avoid it. Just change it. Say I love the CPU free. Okay, or maybe you have some while loops. Okay, want to burn a CPU core. Go ahead. Okay. Okay. So you love to see a demonstration. I don't know what will happen. Okay, but I don't care. This is not my computer. Real time. Go. Okay. Wow. Out of control. Okay. Okay. Any change? No. No. Okay. Seems no fun. No fun. Then I choose another victim. This guy. Go to die. Wow. Wow. Okay. It's still moving. Okay. So 邊個睇埋呢面? Okay, so no fun, huh? Where is the idle process? I found you. System idle process. Hey, no way to right click. Oops. Seems no fun, huh? What? Maybe this. Win init. Real time. Already high. How about real time? Nothing changed. Okay, so yeah, I know Notepad is real time, but this is faster than normal. Yeah, can you feel that? Yeah, I feel that very fast, right? So this is supposed to be a very slow, okay? Slower than normal. That's still fast. Yeah, I don't know. Okay, but it's still be possible to change. Yeah, I don't know because I'm not really understand the internal of the Windows. Okay, so why I change the real-time process doesn't make any change. Okay, but in Linux we really have ways to change it. Okay, but it involves the root privilege, sketch. So can you see this? In Linux, we can set the affinity, get and set. Okay, which core you love to stay with. The scheduler, you can set the scheduler. Means that you set the static priority, not the nice value. Nice value is another thing. Static priority. In Linux, you can change it. I tried it. Okay, I use my EPC. Okay, use my EPC at one core. Then I can show the power of taking the whole core. I launch a while loop. Not while loop, a loop supposed to loop for 1 million times. Okay? And use the highest priority, I submit it. Suddenly my whole computer freeze. No response, and suddenly it goes back to life. Okay? So it is possible. It is possible. So if you love to, you can join next week elite class workshop. Next week elite class workshop we will try this. Okay. So then what's next? Another is why there is a priority called real time. Real time priority is usually under modern OS. They try to implement something. What is they trying? They try to set deadlines to drop. Some jobs need a deadline, and the deadline means that okay. I use this example. Right? Oh, I use Windows. Okay, say this is a deadline. So what is the deadline? Deadline means D. Deadline at the time equal to something. Okay, I measure deadline length. So deadline length is 1. Very close to the deadline now. So it will go to the priority class 1. Okay, and this is a false example. I cannot find a real time scheduler to share with you. So I create a false example based on some box. Okay, and this example tells me that okay, basically every process has a deadline, and this is the time before the deadline. And if you're having a very urgent call, say this, time to death is 1. Then you will have the priority class 1, and we try to finish your task immediately. Now when the time change, say from 0 to 1, based on the clock value, clock move to 1. Now the deadline is 5, so you're very close to the deadline now, okay, and you will be promoted. Okay, so this is what is about the concept of real-time scheduler. Modern operating system want to emulate this, not really implement it, because it's a total different concept than a normal round-robin scheduler. Okay, so that means I usually try to skip it because I cannot show you real life example. Now how about priority scheduling with multiple queues? Now this is something really implemented. I look up some books. This is an example based on Windows NT. An example based on Windows NT. So what is example based on Windows NT? This example goes with, we have five priority classes. The highest priority usually in other operating systems is the same. Usually the first priority class is the FIFO priority class. Because it's a very urgent job, then you submit using the highest priority. So I will finish you using FIFO. And in Windows NT example, I just change the names here. Say, imagine we can implement SJF. So how about the second priority is SJF? And for priority number 3, maybe priority number 3 is for normal processes. And what is the real concept of a multiple queue priority scheduler is allows you to change from one priority class to another. This is first design features. Another design features is every queue here, there's a Q1, Q2, up to Q5, may have different scheduling method features. Okay, so the methods is here. I have FIFO, I have SJF, I have RR. Other features means if I have different classes here, maybe I change it by staying different quantum values. Okay, this is really created in one of the operating systems that they have 3 priority classes. A normal user can submit to class 3, but not 2 and 1. When people submit to class 3, you will carry 10 time units of quantum. And after you spend the 10 units, that means what? That means you are a CPU hungry process. Okay? And basically this system wants to emphasize that I can finish CPU intensive process fast. So their design is, I will promote you. Okay? Promote you in the sense that I give you more quantum, but your priority will be filled. will be smaller priority. I give a smaller priority, but yeah. But on one hand, I lower priority, but another way is if you can get the CPU attention, you have a bigger quantum. Big quantum. What if 30 CPU time unit cannot satisfy your needs? I will lower you to a further down priority class. Okay? Because you're very CPU hungry, but I need to uphold fairness. So I give ways to new processes. But at the same time, I know that you're CPU hungry. So I will give you more CPU attention by further doubling the quantum values. Or maybe this is the end, okay? I don't have a next level of 80, okay? So this is one type of implementation called multiple queue priority scheduling, okay? And in Linux, the design is like this. Okay, they have I said that they have 100 layers, okay? Different queues. Yeah, this is called others, okay? Is what is the others scheduling class? Other scheduling class is a modified round robin, okay? And in the elite class, we will dig deep into it and have an assignment to hack this, okay? And for others, means you can submit using the set scheduler system call. Then you can go into different queues in red. Okay, you can submit into the red. Very high priority is 99. If you submit a while one loop there, okay, your computer fate is press reset. Pull the power. I don't know what are other ways, okay, just to cut their power. Okay, that while one loop won't stop. Okay, and here we call it real-time processes. Okay, so let me skip this. It's not very important. So we reach the end of this part. The end of this part is basically we have ways try to maximize this. Is RR, right? RR is maximize the effect of fairness. And together, because RR support one thing is if you are on the CPU, you run. If you want I/O, please be removed from the scheduler queue. And when you remove from the scheduler queue, basically, I can make room for people to use CPU. So it is also CPU and I/O balance. Okay, you go to ask for I/O. Okay, then you go. Don't take the CPU time. And policy enforcement, we have the priority scheduler. Okay, but usually it requires root or the administrator privilege. Okay, so this is about this chapter and this part. For this entire part, I never mentioned one thing, and the reason is basically we don't have any best scheduler. We don't have any standard scheduler because we have to design a system that satisfies the needs, right? For Mac OS, their design principle is first give you response. I don't care about the speed. For others, like maybe Linux has a way to boost your, not boost, but give you more CPU time. Okay, give you more CPU time by submitting to a higher priority class or change a nice value. But for others like Windows, I don't know what is their definition of real time. When I change it, only the menu change faster. Okay, I don't know. But different operating system, different needs. Basically, we don't have a best and don't have standard. I can only say that the most frequently deployed methods is round robin. Okay, so that's it about this point. Any problem you want to ask? Any problem?